Welcome students, welcome to lecture number 33 where we will be continuing with module number 4 under subject financial management. So under this particular module, that is investment decisions, we have seen capital budgeting theory, we have seen all the investment evaluation techniques. Okay, so today we are just left with the last part, that is problems on IRR, MIRR and a problem on case study. So today we will be covering problems on internal rate of return, problems on modified internal rate of return, and case study on replacement of capital project. So before we directly move ahead to the problems, let us just quickly revise all this. Okay, so we know capital budgeting techniques divided into two types, traditional and modern. Under traditional, we have payback and accounting rate of return, and under modern, we have seen how to calculate net present value, profitability index, internal rate of return, and modified internal rate of return. So what is internal rate of return, students? That rate of return which you will earn when you make an investment. Okay, and it is that rate where the inflows will be equal to your outflows. That is where the NPV will be 0. So whenever you're making a decision, always you have to compare this rate with the cost. If the rate is more than the cost, then accept. If it is less than the cost, reject. If it is equal to cost, then it is indifference. How to calculate IRR? First, in the problem, you have to check whether the cash flows are equal or unequal. If they are equal, your first step will be to calculate the present value factor. How do we calculate present value factor? Initial investment divided by average annual cash inflows. Okay, next what you have to do is this PV factor you have to plot in the annuity table. Annuity table is table number 4. Present value annuity table is table number 4 in your FM tables. Suppose if the PV factor is not an absolute number, then you have to use a formula. Suppose if the IRR is lying between two factors, then you have to use the formula. This is the formula, that is x plus px minus I divided by px minus py in the bracket y minus x, where x is the lower discount rate, y is the higher discount rate, px is the PV of cash inflows at x, and py is the PV of cash inflows at y, and I is the initial investment. Then how do you calculate IRR when the cash flows are unequal? So you always use trial and error method. In this, you're going to take first rate, but this first rate, how will you identify that what is the first rate you have to take? Is you have to first find the PV factor, then and you know how to calculate PV factor, that is initial investment divided by average annual cash inflows. How do you calculate average annual cash inflows? Total cash inflows divided by life of the project. You will get a particular factor. Suppose at that rate, you will get a factor. Then this factor corresponding to the number of years, you have to find out IRR. Suppose at this rate, NPV is not 0. You have got a positive answer. Then take a little higher rate. If you're getting a negative answer, obviously you know the answer is between the positive and the negative figure. Then is modified internal rate of return. Modified internal rate of return, how to calculate it? There's simple 3 steps. If you follow, you will get the answer. So the first step is you have to calculate PV of cash outflow. Second step, find out the future value of cash inflows and then equal this to. Equal is PV of cash outflow is equals to PV of future value of cash inflow. So it will be step number 1 is equals to step number 2 divided by 1 plus R raised to N. So when you solve this, you get what is MIRR. Again, you have to compare this MIRR with the cost. If it is more, accept it, less, reject it, and equal, then it is indifferent. Then we had seen case study on replacement of capital project. So when is, like, suppose if a business has to take a decision as to when it has to replace its old asset and purchase a new asset, on what basis it will take the decision? Either it can use the technique of NPV technique or IRR technique. So whenever he is using NPV technique, okay, you have to find out NPV of only the incremental cash inflows. Incremental is over and above. Okay, suppose if the NPV is positive, accept it, negative, reject it. IRR technique, again, as I've already revised now how to find out IRR, but IRR also has to be find out only of incremental cash flows. Like suppose if you are purchasing the new machinery, so what will be the increased inflows or outflows? If IRR is greater than K, accept it. If it is less than K, rejected. So this was a quick revision about IRR, MIRR and replacement of capital projects, which can come as your case study. So now let us see problems on IRR, MIRR and the case study. Okay. Now is this Word document clear, visible to everyone? Yes, students?
Yes, ma'am.
Is it visible to everyone?
Yes, ma'am.
Okay. Let us start now with the problems on internal rate of return. A company is considering the following proposal with the initial outflow of rupees 10,000 with the following cash inflows. So the inflows for the first year is 1,000, second year 1,000, third year 2,000 and fourth year 10,000. Compute IRR if the opportunity cost is 14%. Now students, in case of IRR, first you have to identify whether the cash inflows are equal or unequal. So can anyone tell me whether the cash inflows are equal or unequal? Yes? Quickly students. Are you getting the equal amount of cash inflows every year or it is unequal? Yes? Yes students?
Unequal.
Unequal. So when the cash inflows are unequal, what you have to do is you have to use trial and error method. We have seen that, correct? Now, for that you have to pick up one rate. Now, what is that
Unequal.
first rate that you're going to pick up? Equal. Cash flows are equal. Every year the cash flows are unequal, right? Okay. So what is the first rate that you're going to pick up? So obviously, see, we have seen in our PPT, when the annual cash inflows are unequal, the IRR is to be calculated using trial and error method. So how do you determine the first trial rate? So first find the PV factor. So let us do that. So let us first calculate the PV factor for the project. How do you calculate PV factor? It is initial investment divided by average annual cash inflow. Okay, so what is initial investment already given in the problem? It is the cash outflow is rupees 10,000. So this is already given in the problem. You will write this as 10,000. Next, average annual cash inflow. Is it ready-madely given in the problem? Is the average annual cash inflow given in the problem? No. So we have to calculate it. Now in our theory part, we have seen how to calculate average annual cash inflow. It is total cash inflows divided by life of the project. So what we will do a working note for that. So you have to write C note 1. Here in note 1, you're going to calculate the average annual cash inflow. So for average annual cash inflow, you have to add up the cash inflows of all the years and divide it by the number of years. So 1,000 for the first year, 1,000 for second year, 2,000 for the third year and 10,000 for the fourth year. Add this up, okay, and divide it by 4. You will get the average annual cash inflow as rupees 3,500. Just substitute this figure in the formula 3,500. You get the PV factor as 2.8571. Okay, students. So here, then use the annuity table to obtain the IRR. So we have to go to the annuity table. Okay, we have to see for the number of 4 years are given. So for 4 years, okay, if the PV factor is 2.8571, then what is the rate? So we go to the FM tables where you have to see table number 4, present value interest factor for an annuity. Okay, since here it is a present factor for multiple cash flows, which is an annuity, therefore. So you have to see in this number of years is 4. Do not see any other year because clearly the number of years is given in the problem is 4. So only in this particular row you will be searching your answer. Okay. So now what is the PV factor? 2.8571. So where is 2.8571? So can anyone tell me where it is? Can anyone tell me which rate will you use as IRR? Which number is nearest to 2.8571, or there is an absolute number 2.85? Can you see it anywhere? Yes, students? You have to see only in this particular row because that is 4 years is given in the problem. So can anyone tell me what rate are you going to take? Yes, students? What is the rate you're going to take?
15%, ma'am.
Very good. We are going to take 15% because here it is 2.85 and 71 is 550. So it is nearing to 2.85. So in the present value annuity table, the nearest value near to 2.8571 for 4 years is found in 15%. Now, is IRR 15?
Ma'am, between 15 and 16.
See, yes, but we are using trial and error method, students. That is when cash flows are equal, your answer is correct. It lies between two. Okay, now here, when cash flows are unequal, first you have to obtain the IRR, which can be a nearest number. Okay, now, which can be a nearest number. So 15%, and you're correct, it is lying between 15 and 16%, but this is 2.85, and there also in 15% also we got 2.85. Okay, so in the present value annuity table, value near to 2.8571 for your 4 years is found in 15%. Now, is our IRR 15%? Is 15% our IRR? How to cross check that? To cross check that, we have to know that by using 15%, if NPV is coming 0, then our IRR is 15%. If NPV is not coming 0, that means we have to search for one more rate of return. So let us use 15% as the rate and calculate IRR. Oh, sorry, let us calculate NPV. So students, see here, years is given, cash inflows is already given in the problem. I use the PV factor at the rate of 15%. I found out the present value. Okay, and then I will find out the NPV. So how to take this PV factor at the rate of 15%? Which table are you going to refer for this single factors? Which table are you going to refer to find out single factor of an present value? Yes, students. Now, is my IRR 15%? For that, I need to calculate NPV. If answer of NPV is coming 0, then yes, my IRR is 15%. If answer of NPV is not coming to 0, then I have to hunt for the second rate of return. So, can anyone tell me from where I'm going to pick up these factors? Present value at 15%? Yes?
Table number 3.
Table number 3.
Very good. So table number 3, you're going to go at 15% for 4 years. 1, 2, 3, 4. So that is 0.8696, 0.7561, 0.6575, 0.5718. So as it is, you're going to write it here, multiply these factors, you will get the present value of cash inflows as 8659. That is 8659. Then you're going to calculate NPV. So NPV formula, as you already know, PV of cash inflows minus PV of cash outflows. Inflows we have calculated. Outflow, students, is already given in the problem. See here. Outflow is already given in the problem, 10,000. So minus 10,000. So can anyone tell me? So the answer you got is minus 1341. So can anyone tell me, can 15% be your IRR? Or should we hunt for a next rate? Yes. Is 15% your IRR? Yes, students?
No, ma'am.
No. Why it is not the IRR? Because at 15% NPV is not coming as 0. So it is not your IRR. So we have to find out the next trial. This once we tried, we failed. We did not get the correct answer. Now do the next trial. To do the next trial, on what basis are you going to select the next value? Okay, so students, see here, if NPV is in minus, if it is negative, you have to select a lower discount rate than 15%. If it is positive, you have to select higher discount rate. Now it is negative, means we have to randomly select a or do a trial of such a rate which is lower than 15%. Now you can take anything. So I have taken in this as 10%. Okay, I have taken it as 10%. You can take it as 11% and solve the answer. You can randomly take it as 12% and solve the answer. You can take it as 9% and solve the answer. So I have randomly taken, since NPV is negative, we need to select a lower discount rate. So we take a trial of 10%. So again, the same steps I follow. I write the cash flow, I write the PV at the rate of 10% from table number 3. Okay, and I calculate PV of cash inflows. Now, how are you going to calculate NPV? Same. NPV at 10% is PV of cash inflows minus PV of cash outflows, so which you're getting is as rupees 67. So is 10% your NPV, student? Sorry, is 10% your IRR? At 10% we are getting positive 67. So is 10% your IRR? Yes, students? Yes. Yes.
No, ma'am.
No. Why? Why no?
Because the NPV is not zero.
NPV is not zero. Very good. So now we know we have got positive 67, and here at 15% we had got negative 1341. So we know zero is lying between a positive and a negative number. Between that zero lies, right? So to find out that NPV should be zero, we know that the IRR is between somewhere 10% and 15%. The NPV is the IRR, because obviously between positive 67 and negative 1341, somewhere zero will come in between. So we know IRR is between 10% and 15%. So if we know it is between the two numbers, we can find it out using the formula, okay, which I've already explained. So IRR may be found out by interpolation between 10% and 15% as follows. So IRR, you write the formula, okay. So where IRR is internal rate of return, Y is the higher discount rate. Between 15% and 10%, which is the higher rate? 15%. Lower discount rate is 10%. PV of cash inflows at X, that is at 15%. What is the PV of cash inflows? That is at the lower discount rate. PV of cash inflows is 10,068. And at Y, what is the PV of cash inflows? It is 8,659. Okay, and initial investment is 10,000. What you have to do, just substitute the figures in the formula. So all the figures are substituted in the formula, and then you will get the IRR as 10.24%. Now at 10.24%, your NPV will be 0. Okay, so this is the calculation. Now how to solve this formula, you all know, right? First solve the numerator, then solve the denominator, divide the two, then multiply with this particular figure in the bracket, and then add it to X. So now the IRR is 10.24%, and the cost here in the problem is given as 14%. So you all make a decision and tell me, should we accept the proposal or reject the proposal? IRR is 10.24%. The opportunity cost, that is K, is 14%. Should we go in for the proposal or should we reject the proposal? Yes, students? Yes, students, should we reject the proposal or accept the proposal?
Reject.
Students, I accept or reject? Yes? Yes, students? The rate of return is 10.24%. The opportunity cost is 14%. That is, cost is 14. IR rate of return that you're going to get from your investment is 10.24%. Should we accept this proposal or reject the proposal? Yes. Yes, students. Are you all there?
Reject.
Correct. We have to reject the proposal because IRR is less than K. So here K is 14%,
Reject
IRR
the
is
proposal.
10.24%. Since IRR is less than K, therefore the project should be rejected. Very good. So we have completed this problem. Now students, presentation, one more thing I'm telling you in your exam. This, these two columns, you are going to write it 2 times, correct? Either it is left to you all, either you solve it two times, or in this same table, you can select the next discount rate and solve it. So this presentation, either you can do up to here and then again do this particular table, redo the table, or in the same table you can add 2 more columns for the next discount rate to be applied, or next rate of return to be applied. So this is presentation, totally depends. Either you can directly solve it in one table or make 2 different tables. The presentation part is left up to you all. Okay. Is this problem of IRR clear to everyone? Yes, students? Yes. Is it clear? Yes, students. Can we move ahead to the next problem? Okay.
Yes, ma'am.
Next, we'll do problem on modified internal rate of return. So students, modified internal rate of return, only there are 3 steps to find out MIRR. What are the 3 steps? First, you will find PV of cash outflow. Then you will find future value of cash inflows. Then you'll equal those two. Equal means PV of cash outflow is equals to PV of future value of cash inflow. In these 3 steps, you're going to get your answer of MIRR. So let us see this problem. Okay, X Limited is evaluating project that has the following cash flows at cost of capital as 10%. So your cost is 10%, that is K. K is 10%. Year 0, 1, 2. See students, whenever in year 0, if it is minus 800, if the cash flow is minus 800 means it is a cash outflow. Cash inflow will always be in positive. Cash outflow will always be in negative. Okay, so if it is minus 800 means you should understand it is cash outflow. If it is positive 5000 means you should understand it is cash inflow. Again in year 2 it is minus 5000 means you should understand it is a cash outflow. Okay, so calculate MIRR. MIRR, only 3 steps you can get the answer. So step number 1, calculation of present value of cash outflow. How do you calculate present value of cash outflow? Write the number of years and cash outflow as it is from the problem. So in year 0, there is a cash outflow of 800. In year 2, there is a cash outflow of 5000. Now, you have to apply the present value factor at the rate of 10%. It is given here 10%. So, can you all tell me which table I need to refer in order to get this factor? Their single cash flows factor you have to calculate. So can you quickly tell me which table should I refer? Yes. Yes,
Table number
students.
3.
So you go to table number 3, 10% for 2 years, that is 0.8264. So you got 0.8264, and I've always told you PV for the year 0 will always be 1. So you multiply this two, okay, you get the present value of cash outflow as 4932. Your second step, calculate future value of cash inflows at 10%. Now future value, there is only one cash inflow, that is 5000. So year 1, 5000. Now future value at 10%. Students, now which table I have to refer for future value of single cash flow? Can you all tell me which table I have to refer for future value of a single cash flow? Yes, students?
Table number 1. 1.
Table number?
1.
Very good. So table number 1, you will go and at 10% for 1 year, that is 1.1000. So 1.1000 you got, multiply this 2, you will get 5500. This is future value of cash inflow. This your step number 2 is clear. Now what is your step number 3? It is you have to equate the step number 1 and 2. So make step number 1 equal to step number 2. So PV of cash outflow should be equal to PV of future value of cash inflow. Why PV? Because both should be comparable. You cannot compare future value with present value or present value with future value. To make it equal, to make it comparable, you have to bring down this future value to the present value. So present value of cash outflow is equal to present value of future value of cash inflow. So here you have written, you have got the answer, present value of cash outflow already in step number 1 you have got, that is 4932. You write it as it is. Now future value of cash inflow you know is 5500. Now if you want to find out the present value of 5500, you have to divide it with 1 plus r raised to n. Now n is 2 years. Here only 2-year figures are given, so n is 2 years. Okay, and we have to calculate r. This r is nothing but MIRR. So you have to solve this particular formula. How do you solve this formula? Cross multiply these two. Okay, after that you have to bring this 4932 to the right hand side, divide it. Okay, and then when this raised to 2, if you're transferring on your right hand side, it will be raised to the power of half, that is 1 by 2. And when you solve this particular equation, you will get the MIRR as 5.6%. Now you tell me, should the project be accepted or rejected? Your rate of return is 5.6%, but your cost is 10%. Will you accept this proposal or reject? Yes, students? Yes? Will you accept the proposal or reject the proposal? Yes? Students, your rate of return, you're getting it as 5.6%. Okay, your cost K is 10%. Will you accept the proposal or reject the proposal?
Reject the proposal.
Okay, very good. So MIRR is very simple calculation, only 3 steps and you get the answer of MIRR. So let us do one more problem on MIRR. Okay, P Limited is evaluating a project for the following cash flows associated with it. So from year 0 to year 6 you have. Now tell me, you all have to tell me whether it is a cash inflow or outflow. For year 0, minus 120, it is a cash inflow or outflow? Yes, students? Minus 120.
Outflow.
Okay, in year 1, it is minus 80. So it is an inflow or outflow?
Outflow.
From year 2 to year 6, it is positive
Outflow.
figures. So from year 2 to year 6,
Inflows.
inflows. Very good. Find MIRR. So can you all tell me the first step?
Inflow.
Can you all tell me the first step to calculate MIRR? You have to calculate present value of cash outflow. So your PV of cash
Calculation
outflow.
of PV.
So you all have told me you have to take year 0 and year 1, which has negative figures. So cash outflow is 120 and 80. Now here the rate is, the cost is given 15%. So present value at 15%, you have to use table number 3. So we always know PV for the year 0 is 1. Okay, and PV at rate of 15% for 1, if you see the table, you will get the answer as 0.8696. Then you find out the present value of cash outflow by multiplying this two. So you get the present value of cash outflow as 189.57. Can you all tell me what is the next step? What is the next step you're going to calculate? Yes, students, for MIRR, what is the next step? First step is finding out PV of cash outflow. What is the next step? Yes? Yes, students, what is the next step? There are three steps, right? The first step is calculating the present value of cash outflow. The second step is calculating future value of cash inflows. Okay, so inflows is from year 2 to 6. Okay, that figures I've written respectively from the problem. Future value at the rate of 15%. Now, can you tell me from where I have taken these figures? Yes, students?
Table number 1.
Table number 1, I've taken these figures. I've multiplied this two. I've got the future value of cash inflows as 467.08. What is your third step in MIRR? You're going to equate the both. Equate the both means present value of cash outflow is equal to present value of future value of cash inflows. So this value I've taken from step number 1, that is 189.57. I've taken from step number 1. Okay, this 467.08 I have taken from step number 2 divided by 1 plus r raised to 6. This 6 I have taken because number of years given in the problem is 6. When you solve this particular formula, you will get R, and that R is nothing but your MIRR. Now here you got it as 0.1624. Always rate is always in the form of percentage. Therefore, you have to multiply it with 100. So your rate is nothing but 16.24%. Now tell me whether you will accept this particular proposal or reject it. Your cost is 15%. Your rate is MIRR is 16.24%. Are you going to accept it or reject it? Yes, students?
Accept the proposal.
Very good. Now, I hope you have understood IRR, MIRR. Now, let us see one case study on replacement of capital projects, like whether you have to replace it or whether you have to continue with the existing asset. So, I'll just show you this case study. XYZ Limited, okay, whose required rate of return is 10%, is considering replacing one of its plant by its new plant. So it wants a new plant to be replaced with its old plant. The data of both the plants are given. That is, what is the cost of existing plant? 24,000. Proposed plant, if you're going to purchase, the cost is going to be 54,000. Remaining life of both the plants is 6 years. Depreciation is 4,000 for existing plant. For proposed plant, it is 9,000. Scrap value is 20,000 for existing plant, and proposed plant, it is obviously 0. Profit before depreciation tax 8,000 and 15,000. Evaluate the proposal as per both the NPV and IRR technique, given that tax rate is 40% and the loss on disposal of asset is not deductible. Now, students, we have already seen that in NPV technique, the first step is whatever is the required rate of return, you have to consider it as the discount rate. So let me show you the presentation. Dear students, in NPV technique, use the required rate of return as discount rate. Next, calculate NPV of incremental net investment and incremental cash flows. Means incremental means only excess. Now, let us first do the NPV technique. And if the answer of NPV is positive, accept, negative, reject. So first what you have to do is find out incremental cash outflow. Now students, I will first explain how. Suppose students, you are purchasing the new plant. New plant cost is 54,000. Obviously, if you're purchasing new plant, means you have to discard the old plant, and the scrap value of the old plant is 20,000. So what is your net? 20,000 you're going to receive and 54,000 you're going to invest. So what is your net cash outflow? Can you tell me what is the incremental cash outflow? Yes. When you're purchasing your new plant, you are selling your old plant, you're getting a scrap value of 20,000. And the new plant cost is 54,000. So what is your incremental cost? Yes. Are you understanding incremental cost means which cost? See, normal cost is 54,000, but incremental cost is over and above this. What cost you will be incurring? See, you're going to sell the old plant, because if you're purchasing new plant means you have to sell the old plant. When you're selling the old plant, you're getting a scrap value of 20,000. Means you're receiving 20,000. but the new plant cost is 54,000. So how much will go from your pocket? What is the net cash outflow that is going to happen from your pocket? Yes. Yes, students.
34,000.
Okay. Very good. 34,000. Cost of the proposed plants is 54,000 less scrap value, because this is the value that you're been getting. So you have to minus it. So what is your net cash outflow? It is 34,000. Very good. Now here we have seen you have to calculate NPV of incremental net investment, that is cash outflow, and incremental cash inflow. So outflow we have calculated. Now let us calculate the incremental cash inflow. So first we take this for existing plant and proposed plant. If you minus those both, you will get the incremental cost, incremental cash inflows. So profit before depreciation, obviously you know students, tax is to be deducted, okay, after deducting depreciation. But when you calculate cash inflows, you have to add back depreciation, because depreciation is a non-cash item. So profit before depreciation is given for both the plants. You write it as it is. You are lessing the depreciation for both the plants, which is given in the problem. You get profit before tax. You have to less tax at the rate of 40% on 4,000 and 6,000. Okay, then you get profit after tax. To this profit after tax, you have to add back depreciation. Why? Because you want to know cash inflows, and depreciation is a non-cash item. You had deducted depreciation because you wanted to deduct tax. Now cash inflows means you will get a 6,400 and 12,600. Now how do you calculate incremental? Incremental means proposed plant minus existing plant. So that is that increased income or increased expense inflows that you will be getting, okay, if you go in for the proposed plant. So minus 15,000 minus 8,000, 7,000, 9,000 minus 4,000, 5,000, 6,000 minus 4,000, 2,000, and so on. You have to minus in order to get the incremental. So now you got the incremental cash inflows. Correct? Now you have to bring this down, discount it, and get it to the present value. So this is the present value of the annuity, because it is 6,200 for 6 years. Remaining life is 6 years. So you will use the present value annuity factor, that is 10% for 6 years. You will see table number 4, multiply 6,200 minus the cash outflow, that is 54,000. You got NPV as minus 6,999. So should this replacement be done or it should not be done? What is your answer? If you get the NPV as negative, should the replacement should be done? Yes, students?
Not done.
Not done. So since the NPV is negative, the proposal should be rejected. The replacement should not be done. The proposal for replacing the old plant by the new one should be rejected. So company should not go in for the new plant. It should continue with the existing plant. Next is IRR method. What they're telling us, solve this particular replacement answer with both the methods. So IRR method, first you have to always, you know that IRR method means we have to calculate the PV factor. How do you calculate PV factor, students? What is the formula for PV factor calculation? Yes. First step in IRR is to calculate the PV factor. How do we calculate PV factor? What is the formula? Yes. What is the formula to calculate PV factor? Yes, students, what is the formula?
Initial
Initial
investment
investment.
divided by annual cash in.
Very good. So initial investment is given in the problem, that is incremental. Again for IRR also incremental you have to use, because here I have shown you all here of incremental cash flows. So it is 34,000 incremental cash flows divided cash outflow, that is investment. Incremental investment is 34,000 divided by incremental annual average cash inflows, which is 6,200 here. Okay, when you divide this two, you get the PV factor as 5.5. you have to see this for 6 years. Okay, so now let us plot it. So which table are you going to use? Table number 4. For 6 years, 5.5. Where it is lying, students? 5.5 for 6 years. Yes. Where is 5.5? Under which rate? Where is IRR? Under which rate it is falling? Under which two uh, percentages of factors it is falling? Only see 6 row. Don't see any other row because your n is given 6. Now 5.5 is the answer that you got, that is incremental cash outflow divided by annual average cash inflows. You got the answer as 5.5. So can you plot this 5.5 here anywhere? Yes, students? Yes. Where is 5.5? Under which factor, under which percentages it is lying? Students, are you all there?
2% and 3%.
Very good. Between 2 and 3%.
2%.
Okay. Do I need to, means we know IRR is between 2% and 3%, right? Right, students? Yes?
Yes, ma'am.
Yes. Okay. So we know IRR is somewhere between 2% and 3%, but the cost in this particular problem is 10%. K is 10%, IRR is between 2% and 3%. So do you want to actually again, solve the problem using the formula? Like if the IRR is between 2% and 3%, you can calculate IRR by using a formula which we have seen. Is that required? Or now you know that K is less, is between 2 and 3%. Sorry, K is 10% and your IRR is between 2% and 3%. So based on this, can you make a decision, or is it necessary for you to do the formula and then find out what is exact IRR? Are you understanding? Your K cost is 10%. Your IRR is between 2% and 3%. Based on this, can you make a decision? Or should you find out the exact IRR by using the formula to make a decision? Or up to here, is it okay? What decision will you make? Your cost is 10%. Your IRR is between 2% and 3%. You don't know exact percentage, but it is somewhere between 2% and 3%. So what decision will you make? Yes,
Reject the proposal.
the proposal.
Reject the proposal.
Reject the proposal because, see, now on the basis of the future value annuity, present value annuity table, the value nearest to 5.5 for 6 years is 2% and 3%. Thus, we know that the IRR is lying between 2% and 3%. Since IRR is less than the cutoff rate is 10%, it is less than that. The proposal should be rejected. The old plant should not be replaced with the new plant. The firm should continue with the existing plant. So under NPV method also we saw how to take a replacement decision, and under IRR method also we saw how to take a replacement decision. Now, can anyone tell me why we didn't do formula and found out the exact IRR? Was it required? Because obviously when we know the cutoff rate is 10% and we know IRR is between 2 and 3%, means obviously the rate of return is less than the cost. Then simply unnecessary, you need not solve it using the formula. Is this problem clear to everyone? Yes, students? Yes? Did everyone understand this particular problem? Yes, students? Did everyone understand the problems on IRR, MIRR and case study? Yes, students? Students, are you all there? Are you listening? Am I audible? Yes.
Yes, ma'am.
Thank you so much, students. We are done for